Hello, good morning. I'm discussing nanocrystalline zinc oxide. Zinc oxide is regarded as one of the key technology materials. It is unique materials which shows semiconducting piezoelectric property of certain materials to generate an electric charge when subjected to mechanical stress or deformation, and pyroelectric property of certain materials to generate an electric charge in response to a change in temperature property. It can form diverse structures whose configuration are much richer than any of the known materials, including carbon nanotubes. Nanorods, which are ferromagnetic at room temperature, and it opens a way to use zinc oxide nanorods as nano size read. The nanorods, which are ferromagnetic at room temperature, and it opens a way to use zinc oxide nanorods as nano-size read-write needs for data for magnetic data storage. It is found that the gas changing ability, photon to electron conversion efficiency, and photonic performance would be enhanced. It is found that the gas changing ability, photon to electron conversion efficiency, and photonic performance will be enhanced by reducing the dimension of zinc oxide structure to nanoscale range due to the increase in surface area and quantum confinement effect. Uses of zinc oxide nanomaterials. Zinc oxide nanostructures are the building blocks of new generation electronics and are potential candidates for semiconductors, piezoelectric materials, nanosensors, nanocantilevers, short wavelength light emitters, luminescence device, gas sensors, UV laser, solar cells, biosensors, etc. Zinc oxide nanostructures have many uses when fabricated as nanoparticles and nanorods. They can be used in food products such as breakfast, cereals, as source of zinc. They also use in dentistry, ointments, creams, lotions, etc. to protect against sunburn UV. They can also access a gas sensor for finding the gas leakage. In the electronics, they have brought a revolution in laser and light emitting diodes. Zinc oxide nanostructures as piezoelectric sensors. The control over flow of current in one-dimensional zinc oxide nanostructures can be achieved by change in electrical charge distribution during the bending. Nanotubes and nanowires developed by the piezoelectric materials have a property of charge separation, positive on one side and negative other side during the bending. This fundamental property of nanowires and nanowells can be used in developing piezoelectric sensor to detect force in the nano and piconewton range by just measuring the change in the current flow through the array of nanostructures. These sensors can be used for measuring the blood pressure in humans. Zinc oxide-based nanogenerators are generating significant amount of charge by bending and releasing the array of zinc oxide nanowires. Zinc oxide nanowires and nanotubes have special advantages which make them potential candidates for an integrated nanosystem. Advantage of piezoelectric sensors: a large amount of deformation without damage This enables their use in flexible electronics like folding power source, which permit large volume density of power output. Biocompatibility, this allows usage in the body without any toxic effects. Zinc oxide nanostructures as biosensors, zinc oxide nanostructures used as the signal enhancing platforms for rapid multiplex high throughput high sensitivity and sensor arrays. Zinc oxide nanostructure can be effectively used for identification of biothreat agents by successful discrimination of DNA sequence from other genetically related species. Zinc oxide nanomaterials are critical for the detection of hybrid DNA as they achieve increased fluorescence. Zinc oxide nanosters as solar cells. Solar cells based on zinc oxide nanosheets exhibit better performance than the nanoparticle-based solar cells or warranted nanowire-based solar cells. Zinc oxide nanosheets have certain advantages, including the dispersion of loss during the photoelectron transport, increased dye compound absorption, and enhanced incident light capture. Zinc oxide nanocrystalline sheets self-assemble on a flexible polymer substance, acts as electrodes for dye-sensitized solar cells. This provides an opportunity to integrate solar cells with nano devices and microcircuits, which makes it work with self-supplied solar energy. Zinc oxide fails with nanosheets microstructure appears as a matrix of randomly oriented nanosheets. It combines with a flexible substrate more stably and handles deformation well with increased photon capture. Zinc oxide nanostructure is gas sensor. Zinc oxide gas structure have attracted great interest as gas sensors because of their high chemical sensitivity of different observed gases amenably towards dropping non-toxic property and low cost. The sensitivity of zinc oxide nanowires to detect part per million levels of acetone and ethanol has been reported. Okay, it's all about zinc oxide line, zinc oxide. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you again.